Okay, so this is lesson 2, and we're going to look at the first two properties. These are both closely linked. So what we're looking at is the angle at the center is going to be twice the angle at the circumference. So again, we're kind of reviewing what we did before with the terminology. These are going to be the angles at the circumference, and then this is the angle at the center. So we're going to look and prove why this is true based off of this triangle that you see in the book, and this is on page 328. Okay, so they've given us this angle is 25 degrees. We know that this is a radius of the circle, and this is also a radius. So those two lines will be equal. We know if the lines are equal that the angle will also be equal. So that means this is equal to 25 degrees, and this is also a radius as well as this one. If this angle is 40 degrees, this one will also be 40 degrees. Now, how does that help us? For this point, we need to figure out then what these other angles will be equal to. Well, we know there's 180 degrees in a triangle, so these two equal 50. So that means this angle, we're going to erase the O for a minute so you can see it, this angle then has to be 130 degrees. This is a straight line. We know that's 180, so the difference there would have to be 50 degrees. All right, we can do the same on the other side. This is 40 and 40 is 80. That means this angle has to be 100 degrees, meaning this angle has to be 80 degrees. Okay, so what we're trying to say with this theorem is that these angles at the circumference are going to be, these angles here are going to be twice as much as those. So let's see if that's true. 25 plus 40 is 65, and 50 plus 80 is 130. So indeed, that is true. So this is proving that angle, that the angle at the center is twice the angle at the circumference. So again, you can see it's not this inside angle, it's the outside angle that you're going to be looking for. So make sure that you are looking at the right angle. It's kind of the reflex angle. It's the one on the outside. This one is also closely related to it. Again, I'm looking out for certain things in circles to try to make me think of, oh, which property is this? This is definitely one of those. And anytime I see a diameter, I see two semicircles, right? The diameter is going to break this circle into two halves. Right now it's two halves horizontally. Anytime we have that, anytime you have a semicircle, you will always have a 90-degree angle. And if you think about it, it's the same theorem as this one. This angle here is a straight line, which is 180. So that means the angle at the circumference is half the size, so it's 90. So it's essentially the same theorem, but I just know anytime I see a semicircle, there's always going to be a 90-degree angle. So it's really important to kind of just have those things that you look out for anytime you see something. So let's look at a couple of these examples and see if you can't figure out what this is going to look like in question form. So again, anytime you're looking at these and you see O, that's always going to be the center, because some of these theorems will involve the center and some of them will not involve the center. So these two do involve the center because we have the diameter and then we have points from the center. So if we look at example 3, this is also one of the things I'm looking out for. This shape here that they give you, I kind of refer to it as a baseball diamond because that's what it reminds me of when I look at it. We have these given to you as O, so we know even though my diagram doesn't exactly look like it, that's going to be the center, and they give you this angle 108 degrees, and they want us to find X, pretty common. So this is exactly the situation that we just saw. We know that the angle at the center, this angle, this reflex angle, is going to be twice this angle at the circumference. So that would put this angle, this reflex angle, 108 times 2. So that's 216 degrees. Now, we know a circle has 360 degrees in it, so that's this whole thing. So to figure out this missing section, which is X, what they want us to find, we can do 360 minus 216, which is going to give us 144 degrees. Again, you could not have solved that without knowing that this angle at the center is twice the angle at the circumference. And again, it's the reflex angle, and then knowing that a whole circle is 360, we can subtract 360 minus the angle that we know to find the missing angle. The next example on the next page that they give you is going to involve a triangle and a diameter. So again, I'm always on the lookout for that. So again, my circle's not very, my center is not very centered, but we're going to go with that. We'll at least try to get my line here connected correctly. So when we're doing this, in this one, they're not even going to give you any angles. They're just going to tell you this is A, this is O, this is B, and P. These are very common letters that they use. They say this is X, this is 2X, solve for X. So we don't even have any values given in this one. So we definitely need to rely on the circle theorem. So again, I see, look, I have a diameter. That means this has to be 90 degrees. There's no way we can solve the problem otherwise. It would have to be given to you otherwise. So we know a triangle has 180 degrees. So 180 equals, we have 90 plus 2x and x, 3x. So we use our nice algebra. For those of you that like algebra, it's a little bit for you. We divide, we subtracted the 90 from each side, divide by 3, and we found that x equals 30 degrees. So that means this angle is 30 degrees and this angle is 60 degrees. So again, no possibility of solving this problem without knowing that property. So again, I'm looking for two things. I have my baseball diamond with the angle at the center is twice that at the circumference, and I have my semicircle that's showing me that I have a right angle. The next one is going to be a lot of different things combined as well. So in this situation, we're going to bring back the tangent as well. So we have O. This one is actually going to look, thankfully, a little bit better than the last one here, as far as being central. And it's all going to connect here from point C. And then we have a tangent coming here off of point T. They like using T for tangent. We're going to call this is where it hits there, off of point T. And they're going to give you this is 46 degrees. We have again A, B, C. Okay, and then they've given you this is P. We don't necessarily need that in this. And they're telling you then that we, in the diagram, O is the center, and TA and TB are tangents. Right away I'm thinking, oh yeah, my circle properties from lesson 1, I know some things about tangents. And they want us to find angle AOB and angle ACB. Okay, so when I'm looking at this, again, tangents, what do we know about tangents? We know that if there is a point that's external here that's going and hitting my circle, then these two lines have to be equal. So if that's the case, then we know that the angles are also going to be equal. What else do we know? We know that when it hits the tangent hits the radius, that this is going to be 90 degrees. We have two of those situations here, don't we? So this one and this side will both be 90 degrees. So I'm just kind of filling in what I know. And they want us to, first of all, find AOB. AOB. This angle. Well, I have right now a four-sided figure. We know that means it has to have 360 degrees in total. And I have 3 of them. So all we have to do is figure out the missing one. So we know 360 degrees. So we can subtract 90 minus 46. And we should be left with this angle AOB. So if we subtracted those, we have 360 minus 180 equals 180. And if we subtract 46, 7, we're left with 134 degrees. It's going to be this one, 134 degrees. So not so complicated, but we needed to know that when our line, the tangent, hits a radius, it forms a 90-degree angle. And that happened on the two sides. Then we looked and saw, okay, we know that if we have a four-sided shape, it's going to be 360 degrees. Now, the next thing they want to find out is ACB. That's going to be this top angle. Again, we just looked at a circle theorem with this. We said the angle at the center is twice the angle at the circumference. So all we have to do, knowing that theorem, is 134 divided by 2. It's really that easy once you understand the relationship that this angle here and this angle are related. So if we do that, we end up with 60, 2 goes into 13 6 times, 67 degrees. So again, you have to make sure that as you're learning these, you're storing them away. The good news is that you will be asked to combine a lot of these things in different circles. So it'll kind of have to make you review them as you go. But really, it's all about looking for the relationships. So look for the baseball diamond, look for the semicircle, look for these situations where you know you have the situations that we've talked about. So go ahead and ask if you have any questions or this doesn't make any sense to you. Thanks.